In the depths of the universe, we're gliding inside a huge spiral. Right now, at this very second, we're on a cosmic journey at 230 kilometers per second. We're not even aware of it, but we're spinning around the center of the Milky Way Galaxy at an incredible speed. This speed means about 600 times the speed of sound. Just think, while you're sitting quietly listening to these words, you're actually traveling in a tremendous cosmic vehicle. This speed might sound very impressive, but the galaxy is so large that even at this speed, it takes us 225 to 250 million years to make one complete revolution around the center. We call this a galactic year. Think about it. Since our solar system formed 4.5 billion years ago, it has only been able to complete this journey 20 times. 20 times. When dinosaurs were roaming the Earth, the Sun was in a very different corner of the galaxy. Since we humans began to exist, our solar system has covered only 1,000th of its galactic orbit. Time takes on a completely different meaning on a cosmic scale. Now let's think about how our galaxy came to be this way. The Milky Way might appear to be a gentle, calm structure, but it has actually behaved like a ruthless cannibal throughout history. Scientists have discovered that our galaxy has grown by swallowing dozens, perhaps even hundreds of smaller galaxies since its formation. This galactic cannibalism is a natural process of the universe. Large galaxies, thanks to their gravity, pull smaller galaxies toward themselves, tear them apart, and absorb them. And this process is still ongoing. Right now, the Milky Way is tearing apart and pulling in the Sagittarius dwarf galaxy. This dwarf galaxy is approximately 10,000 light-years in diameter and is being slowly torn apart by the Milky Way's gravity. Its stars, gas clouds, everything is being pulled in. This process has been going on for hundreds of millions of years and will continue until it completely disappears in the future. The remnants of the Sagittarius dwarf galaxy will live on as part of the Milky Way. This is a terrifying yet fascinating process. However, our galaxy's fate will also be shaped by a similar event. Approximately 4.5 billion years from now, we will collide with the Andromeda Galaxy. But don't worry, this won't be an explosive, cataclysmic collision like in Hollywood movies. Galaxies are so vast, and the distances between stars are so large that when two galaxies merge, the probability of stars colliding with each other is almost zero. Instead, we'll witness an elegant cosmic dance lasting hundreds of millions of years. The two galaxies will pass through each other, then return again. Spiral arms will scatter, new stars will form, and eventually the two galaxies will merge to form a brand new, probably elliptical galaxy. Scientists have already given this new galaxy a name, Milkomeda or Milkdromeda. Andromeda is currently approaching us at about 110 kilometers per second. It's one of the most distant objects we can see in the night sky. On a dark night, away from light pollution, you can even see it with the naked eye, like a blurry spot. That blurry spot contains 1 trillion stars and is coming toward us. But rest assured, by the time this collision happens, life on Earth will probably have long since ended, because by then, the sun will have swollen into a red giant phase. Now, let's turn our eyes to the heart of our galaxy. At the center, there's one of the most mysterious and wildest objects in the cosmos, a supermassive black hole. Its name is Sagittarius A star. This black hole is 4 million times heavier than our Sun, 4 million times. This number is hard to even comprehend. A black hole is a region that swallows everything around it, a place from which even light cannot escape. It sits silently at the center of the Milky Way and governs the fate of the galaxy. Scientists knew of this black hole's existence only from indirect evidence for many years. When they observed the stars orbiting around the center, they noticed that these stars were moving at incredible speeds. Some stars were completing a full orbit around the center in just 15 years. To make them move this fast, there had to be a tremendous mass there. And in 2020, thanks to the Event Horizon Telescope project, we were able to take the first photograph of Sagittarius A star that orange ring went down in history. For the first time, humanity had seen the shadow of a black hole. The galaxy's center isn't limited to just the black hole. There's a stellar bulge, shaped like a peanut or an hourglass. We call this region the galactic bulge. The center isn't perfectly round. It has a somewhat distorted, compressed structure. This is where the oldest stars of our galaxy live. Red giants, yellow giants, stars tens of billions of years old. They're all spinning in a compact way around the black hole at the center. The stellar density is so high that if our solar system were there, the night sky would probably never be dark. Hundreds of thousands of bright stars would illuminate the sky from every direction. Now let's get to one of the biggest mysteries of our galaxy: dark matter. Everything we see, all the stars, planets, gas clouds, dust, all of it makes up only 15% of the galaxy's total mass. The remaining 85% is completely invisible. We call this dark matter because it doesn't emit light, doesn't reflect light, doesn't produce any electromagnetic radiation, but we know it's there because we see its gravitational effect. If there were no dark matter, the Milky Way would tear apart and scatter while spinning at this speed. When we calculate the rotation speeds of galaxies, the amount of matter we see isn't enough to explain this speed. Galaxies are spinning too fast, and logically they should scatter, but they don't, because something invisible is holding them together. This invisible matter surrounds the galaxy like a giant halo and keeps everything in place. Scientists still don't know what dark matter is. Are they new particles? The result of a physics law we don't know? We can't answer yet, but research continues. Now think, what do you see when you look at the night sky? Thousands of stars, maybe tens of thousands. If you're in a dark place and your eyes have adjusted, you can also see the band of the Milky Way, that blurry, milky path. But all of this is deceptive. All the stars we see with the naked eye are only about 3/millionths of the galaxy's total star count. Think about it. That magnificent sight in the sky is only a very small fraction of reality. There are 200 to 400 billion stars in the Milky Way, and we can only see a few thousand of them. Moreover, due to our solar system's location, we can't see large portions of the galaxy at all. We're inside the galactic disk, so we're looking from the inside. This is like standing in the middle of a forest and trying to see the forest. When you look around, you only see trees, but you can't see the entire forest. To understand the true structure of the Milky Way, we'd need to go outside it and look from a distance, but that's impossible. That's why mapping our galaxy is an incredibly difficult and slow process. By looking at other galaxies and drawing similarities, by mapping gas clouds with radio telescopes, and by tracking the movements of stars, we're slowly trying to decipher the exact structure of our galaxy. Some stars in the galaxy have a very interesting fate. We call these rogue or runaway stars. The supermassive black hole at the center launches some stars at incredible speeds, like a slingshot. These stars are hurled outward from the galaxy at speeds of hundreds, even thousands of kilometers per second. This is a speed that exceeds the galaxy's escape velocity, so these stars will never return. They will travel forever toward intergalactic space, a dark, cold, lonely journey. How do these stars accelerate so much? Usually, when binary star systems get too close to the black hole, one star is pulled into the black hole, while the other is launched at tremendous speed. We call this the gravitational slingshot effect. The black hole's gravity is so powerful that it can accelerate objects to incredible speeds. The fastest rogue star discovered so far is moving at approximately 1,700 kilometers per second. That's over 6 million kilometers per hour. At such a speed, you could cover the distance between Earth and the Moon in just 13 seconds. Another interesting point is that some stars rotate in the opposite direction to the galaxy's general rotation. The vast majority of stars in the Milky Way rotate in the same direction, counterclockwise. But some stars move contrary to this, in what we call a retrograde direction. Where did these stars come from? Scientists think that they weren't actually born in the Milky Way, but came from other galaxies. In the galactic cannibalism process we mentioned earlier, when the Milky Way swallows other galaxies, It also absorbs some of that galaxy's stars. But these stars maintain the rotational direction of their original galaxies. Thus, stars rotating in the opposite direction appear within the Milky Way. These are kind of adopted stars. Now, let's look at our situation in our own neighborhood. Does the solar system live in one of the Milky Way's giant spiral arms? Actually, no. Our galaxy has large, distinct spiral arms, like the Scutum Centaurus arm and the Perseus arm. But we're not in these main arms. We're in what's called the Orion Spur, or Orion Arm, a smaller structure located between these large arms. You can think of this like a city neighborhood. The main streets are the spiral arms, and we're in a quieter side street. This is actually quite a lucky situation for us. In the main spiral arms, star formation is much more active, supernova explosions are more frequent, and cosmic radiation levels are higher. Life developing on a planet living there would be much more difficult. But we're in a calm region. The sun is neither too close nor too far from the center. We're far from the dangerous radiation of the black hole, but we're not in the completely desolate outer regions of the galaxy either. We're right in the middle, in a safe zone. This is also called the galactic habitable zone. The conditions necessary for life to emerge exist only in certain regions of the galaxy. The Milky Way isn't a perfectly flat disk. If you could look at the galaxy from the side, you'd see that it's not perfectly flat. The disk is warped, with one end bent upward and the other downward. We call this galactic warping. It's as if you're holding a giant record with both hands and bending it slightly. So where does this warping come from? Scientists think it comes from the irregular distribution of the dark matter halo, or from interactions with other galaxies. Our satellite galaxies, the large and small Magellanic Clouds, tug slightly on the galactic disk as they orbit around the Milky Way. This tugging, over time, leads to ripples and warping in the disk. The galactic disk also has a wavy structure, not just at the edges, but throughout the entire disk there are up and down undulations. You can think of this like waves in the ocean. Stars and gas clouds move up and down along these undulations. The solar system is also affected by these undulations. Approximately every 33 million years, the solar system passes through the middle of the galactic disk and enters denser star regions. During these periods, the number of comets and asteroids hitting Earth is thought to increase. In fact, some scientists suggest that some of Earth's mass extinctions might be linked to these galactic undulations, but this is still a controversial theory. The spiral arms of the Milky Way aren't static either. The arms behave like density waves. That is, the arms aren't structures where matter physically rotates. They're just regions where matter becomes denser. Think of traffic density on a highway. When cars slow down, a density forms. This density moves over time, but the cars themselves don't stay within that density. They pass through. Spiral arms are like this too. As stars and gas clouds enter and exit the spiral arms, the arms themselves rotate at a different speed. That's why spiral arms are constantly changing, dynamic structures in the galaxy. Now let's go back a bit to our galaxy's past. How did the Milky Way form? About a few 100 million years after the Big Bang, the first stars and galaxies in the universe began to form. These first galaxies were very small, only about 1/millionth the size of today's giant galaxies. Over time, through gravity, these small galaxies merged to form larger structures. The Milky Way also began to take shape 13 billion years ago through the merger of countless small galaxies. The oldest stars in our galaxy are 13 billion years old. These stars formed in the early period of the universe, when heavy elements weren't yet abundant. That's why these old stars are very poor, consisting almost entirely of hydrogen and helium. Elements like iron, carbon, oxygen didn't exist yet. These old stars are found in the galaxy's halo and bulge region. Younger stars like the Sun formed from enriched material that emerged after the deaths of previous generation stars. Each new generation of stars carries the legacy of the previous generation. Our galaxy's history is full of mergers and collisions. Every major merger changed the galaxy's structure. About 10 billion years ago, a dwarf galaxy called Gaia Enceladus collided with the Milky Way. This collision was so large that it played an important role in shaping our galaxy's bulge. Thanks to the Gaia satellite, scientists mapped the movements of billions of stars in the galaxy and found traces of this ancient merger. Some star clusters still carry traces from this collision, showing different chemical compositions and unusual orbits. Around 50 to 60 satellite galaxies orbit around the Milky Way. The most famous of these are the Large and Small Magellanic Clouds. These dwarf galaxies, which you can see with the naked eye in the southern hemisphere, have been traveling alongside the Milky Way for a long time. But over time, they too will be swallowed by the Milky Way. In fact, gas clouds torn from the Large Magellanic Cloud are currently flowing toward the Milky Way disk. We call this the Magellanic Stream, and it forms a giant gas arc in the sky. Some satellite galaxies are so small that they contain only a few thousand stars. We call these ultra-faint dwarf galaxies, and finding them is incredibly difficult. They emit very little light in the sky and are almost impossible to observe. But every new discovery helps us better understand the complex structure around our galaxy. These dwarf galaxies are actually the universe's most dark matter-dense structures. 90% or more of their mass consists of dark matter. As you move away from the galactic center, stellar density decreases, but the galaxy doesn't end at a sharp boundary. On the contrary, it fades gradually. Beyond the galactic disk, in the galaxy's halo, there are old red stars and globular star clusters. Globular clusters are spheres of hundreds of thousands of stars tightly packed together. These are the galaxy's oldest structures. There are globular clusters 13 billion years old, and they're like fossils from the early periods of the universe. By looking at these clusters, we're trying to decipher our galaxy's early history. The total diameter of the Milky Way is approximately 100,000 to 180,000 light-years. But there's no precise boundary. The dark matter halo extends much farther than the visible disk, perhaps up to 1,000,000 light-years. So our galaxy is much larger than what we see, and it continues to grow. Every dwarf galaxy it swallows adds new stars, gas, and dark matter to the Milky Way. What do we know about our galaxy's future? Over the next billions of years, star formation will slow down because the galaxy's gas reserves are being depleted. Every time a new star forms, hydrogen and helium are consumed. Over time, there won't be raw material left to form new stars. Currently, the Milky Way produces about 1 to 3 solar masses of new stars per year, but this rate is gradually declining. Billions of years from now, our galaxy will largely turn into a graveyard, consisting of dead stars, red dwarfs, white dwarfs, neutron stars, and black holes. But first, the merger with Andromeda will occur. 4.5 billion years from now, the two galaxies will approach each other. On the first pass, the spiral arms will mix, giant gas clouds will collide, and a tremendous burst of star formation will be triggered. The sky will fill with new, bright blue stars. Then the two galaxies will move away from each other again until their gravities pull them back. On the second pass, there will be more mixing. And finally, about 7 billion years from now, they will completely merge. The resulting galaxy will probably be elliptical in shape, the spiral arms will disappear, and stars will move in chaotic orbits. How will this merger affect Earth? Actually, it won't affect it much directly. The distances between stars are so large that the probability of our solar system colliding with another star is almost zero. But since the galaxy's structure will change, the solar system's position will also change. Maybe we'll be flung farther from the center or pulled more inward. But by that time, the sun will probably have already become a red giant and swallowed Earth. So this merger will be too late for Earth anyway. The universe itself is also constantly expanding. Galaxies are moving away from each other, and this movement is accelerating. Billions, trillions of years from now, The galaxy formed from the merger of the Milky Way and Andromeda will merge with a few members of our local galaxy group, but all other galaxies will go so far away that we'll never be able to see them. Future observers of the universe will only see their own galaxy. They'll think there are no other galaxies. They won't even be able to understand that the universe is expanding because there won't be any distant galaxies left to observe. This universe we're currently in will be completely invisible to future civilizations. Now think, the stars you can see every night when you look at the sky. They're all a small part of our galaxy. The nearest star to us, Proxima Centauri, is 4.2 light-years away. This means that reaching there with our current technology would take tens of thousands of years, and this is just the nearest star. Reaching a star on the other side of the galaxy would take trillions of years. On a cosmic scale, our speeds remain incredibly slow. Even if we traveled at the speed of light, it would take 100,000 years to cross the galaxy from end to end. This makes us feel very small, but at the same time it points to an extraordinary connection. Every atom in your body was once created inside a star. Iron, calcium, carbon, oxygen, all of them. At the beginning of the universe, there was only hydrogen and helium. All other elements were created inside stars, under tremendous pressure and heat, through fusion reactions. When stars died, especially in supernova explosions, they scattered these elements into space, and these elements were used in the formation of new stars, planets, and eventually us. As Carl Sagan said, we are all stardust, literally so. The number of possible planets in the Milky Way is incredible. If we consider that every star has at least one planet on average, that means there are hundreds of billions of planets in the galaxy, and billions of these are potentially in the habitable zone, that is, at a distance where liquid water can exist. Earth-like planets, worlds with oceans. With so many planets, it seems incredibly unlikely that life exists only on Earth. But we haven't found life anywhere else yet. Maybe life is a rare event. Maybe it's everywhere, but very hard to notice. Maybe intelligent life is very rare. Maybe intelligent civilizations are short-lived. Maybe we're alone. We don't know yet. There's a problem called the Fermi paradox. The universe is this big and old. The Milky Way contains this many stars and planets. So where are the other civilizations? Why haven't we received a signal from them yet? Why isn't the galaxy full of alien civilizations? There are many possible answers. Maybe traveling long distances is physically impossible. Maybe every civilization destroys itself. Maybe advanced civilizations are deliberately ignoring us. Maybe sending radio signals is too primitive, and advanced civilizations use other communication methods. Or maybe we're truly very rare, and the nearest other intelligent civilization is thousands of light years away. Our observation technology is advancing every day. The James Webb Space Telescope is searching for signs of life by examining planet atmospheres. In the future, more powerful telescopes will be able to see oceans, continents, even cities on other planets. Maybe one day, we'll find a chlorophyll signature on a distant planet. Or we'll detect biologically sourced gases like oxygen and methane in its atmosphere. This would be a revolutionary moment for human history. Learning that we're not alone in the universe would change everything philosophically and scientifically. But for now, the only life we know of is on Earth. This small blue dot is spinning around a middle-aged, ordinary star in a tiny corner of a giant galaxy. And on this planet, as a result of billions of years of evolution, consciousness emerged. Beings that think, wonder, search for meaning. Right now, as you listen to these words, billions of neurons in your brain are firing. Electrical signals, chemical reactions, and somehow, these physical processes create experience, feeling, thought. Consciousness is a way for the universe to experience itself. We are the means by which the universe discovers itself. Understanding the Milky Way means understanding ourselves, because we are part of the galaxy, not just tourists living on it, but beings formed from its essence, its matter. The galaxy exists in every atom inside us, and we, with our consciousness, are a way for the galaxy to grasp its own existence. This perspective creates a very deep sense of connection. We're not alone. We are the living, thinking part of this tremendous cosmic structure. Grasping the cosmic scale of time is very difficult. A human lifespan isn't even the blink of an eye on the galactic timescale. All of human civilization, from the invention of writing to today, is only a few thousand years. This isn't even 12 millionths of a galactic year. The period when dinosaurs lived on Earth, 180 million years, is less than 1 galactic year. The entire history of the solar system, 4.5 billion years, is 20 galactic years. But the galaxy itself is 13 billion years old. It has spun approximately 58 galactic years. And the universe itself is 13.8 billion years old. The time that has passed since the beginning of the universe is finite, but its future? If dark energy continues to dominate, the universe will expand forever. Galaxies will eventually exhaust all their stars. Even black holes will evaporate through Hawking radiation. Trillions upon trillions of years from now, the universe will be cold, dark, almost completely empty. Only isolated subatomic particles, separated from each other by tremendous distances. And maybe, thanks to quantum fluctuations, a new universe will be born. Or maybe infinite darkness. No one knows. But that's a very distant future. Now, at this moment, the Milky Way is a living, dynamic, magnificent structure. It's constantly changing, evolving. New stars are being born. Old ones are dying. Planets are forming. Life maybe exists on hundreds, thousands of worlds. And we are witnesses and participants of this great story. Not just passive observers, but active beings. Our decisions, our actions, our discoveries, all are part of this great cosmic adventure. In the future, humanity might travel between stars. Maybe we'll establish colonies in nearby star systems. Maybe one day, thousands of years from now, humanity's descendants will live in very distant corners of the galaxy. On different worlds, under different conditions, but all from the same root, children of the same small blue planet. Or maybe we'll never reach the stars. Maybe Earth will remain our only home. But even this should make us more responsible, because the only life we know is here, on this fragile planet. The Milky Way isn't just a galaxy. It's our galaxy, our home, our origin, our destiny. Every time we learn something new about it, we learn something about ourselves too. Every discovery helps us better understand our place in the universe, and this understanding brings humility and admiration. We realize how small we are, but also how special we are. The universe has created beings complex enough to observe and understand it. This is a tremendous privilege. Now close your eyes and imagine. You're rising from Earth's surface. You're leaving the atmosphere behind. Earth is shrinking, becoming a blue marble. You're passing the moon, Mars, Jupiter, Saturn. The solar system is shrinking. The sun is now just a bright star. Millions of other stars around you. You're going farther. The galactic disk is taking shape. You see the spiral arms. You're moving even farther away. The Milky Way is now a small spiral. Thousands of other galaxies around you. You're moving farther. You see galaxy superclusters. The cosmic web of the universe. Billions of galaxies, separated by tremendous voids. You're moving farther. And finally, the entire observable universe. A finite but boundless sphere. What's beyond this? We don't know. Maybe other universes. Maybe nothingness. Maybe mathematics. Maybe consciousness. Or maybe the answer is as deep as the question. Now come back. Take all this journey in reverse. From galaxy clusters to our galaxy. From our galaxy to the solar system. From the solar system to Earth. From Earth to this room, this moment. And here, in this body, you're experiencing this consciousness. From the infinity of the cosmos to this small, limited, fragile being. But this small being can think about all that infinity, can understand it, can admire it. This is perhaps the universe's greatest miracle, matter thinking about itself, the universe knowing itself. The Milky Way continues to spin at 230 kilometers per second. As you listen to these words, the planet is moving in its orbit, the sun is rotating around the galactic center, and the galaxy is also moving within the local galaxy group. Everything is in motion. Nothing is stationary. The universe is a constantly flowing, changing, evolving river. And we're in that river, flowing with it. Maybe after today, when you look at the night sky, you'll see the stars differently. Not just bright dots, but each one like our sun, maybe with planets, maybe with life. The Milky Way band, not just a blurry path, but home to billions of stars, trillions of planets, and you are a small but important part of that tremendous structure. Because you are a way for the universe to experience its own existence, an expression of existence itself. Tonight as you sleep, the Milky Way will continue to spin. Stars will be born and die. Planets will spin in their orbits. The black hole will wait silently at the center. And you, as a small being on a small planet inside this giant cosmic machine, will exist with your dreams, your thoughts, your experiences. This is tremendous. This is magnificent. This is incomprehensibly beautiful. The Milky Way, our galaxy, our home, and we are its children. Born from stardust, endowed with consciousness, filled with curiosity, small lights, striving to understand the universe. And maybe, just maybe, this striving itself is the meaning of all this vast cosmos.